Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. So I did say I'm going to be uploading video tutorials back to back to help you guys prepare for your final examinations, all right? Guys, if you really want to keep me motivated and you really appreciate the content that I'm creating for you guys, please, I keep saying this all the time. You need to share this with your friends. Share the content with your friends, guys. Okay. Get all my videos to, get to 1,000 views. Okay. And over. Okay. Let's please help the channel grow. If you really, really appreciate the work that I'm doing here for you guys, how I'm helping you, please show that appreciation by sharing, watching my ads, okay, sharing with your friends, cousins, whoever that you know that's doing mathematical literacy. That is how you support me and you show that we in it to win it together. Okay, please guys, that's how you keep me motivated, because if the channel, if I'm just getting 200 views, then that means that I'm just putting all this effort for nothing. Okay, it doesn't motivate me at all, and that's what gets me to stop uploading content. So if you really want to get me to that point where I'm really motivated, because it's a lot of work, I don't want to lie. Okay, it's a lot of work for me to just get 200 views. So when you really, really appreciate it, please share, get your friends to watch, tell them to watch it, watch, share on TikTok, share guys, share all these videos on TikTok. They really help guys. This channel really helps. Okay, so please, let's get this channel to reach more learners in our country that are struggling with mathematical literacy. By you liking before you leave this video, by you liking and sharing, that's how you show that support, guys. Please. Okay, the likes must go with the views. It must be like, the more the views, the more the likes. It must balance. Okay, so please guys, please share my channel. Let's push this channel to reach more learners in this country. Currently this channel is watched by learners in Cape Town, Pretoria, right? So it's a bit of a concern, and so it's a bit of a concern. It kind of shows me that this channel is not really reaching every single learner. So let's get it to reach every single learner, guys, by sharing the channel. So in this video tutorial, we are going to be looking at volume, but obviously this volume question is not coming to us dressed up the way that we are used to. Okay, it's coming in a different form. Okay, so that is why it's very important that we look at these application questions, because they require us to think at a deeper level. All right, so please make sure you seated in a quiet place, you've got your notebook out, and let's get started with today's video tutorial. Right, so question 3.1.4, it says the paint is filled to 90% of the capacity of the tin. The diagrams and the dimensions of the paint are given below. So we are given a diagram that kind of shows us what is the picture of gives us a picture of a paint tin, and we're also given the diagram of paint tin with the dimensions. So they give us that, okay, the diameter of this tin is 8.92 centimeters. They give us the height of this tin. We do not know. Right? Cool. So it says use the information above to answer the questions that follow. So now let's start off with the statement that is given to us there. Okay, we're given a statement there. Okay, so from this statement, we are basically told that, okay, let me just do this. We are basically told that the paint is filled to 90% of the capacity of the tin. So that's basically telling us that this tin has paint inside, right? And they haven't really filled up this tin to 100% its capacity. So that basically means that, okay, if this is my tin of paint, okay, it basically means that maybe, okay, it's filled up to that level. Let's just say that maybe that's 90%. Okay, so it's filled up to that level, right? Okay, it's not filled up to the brim or the top. it's just filled up to 90% of its capacity, right? So there's obviously the height of the paint there, okay? That's the height of the paint. Then we're also given the diameter of the tin. So the diameter of the tin is equal to 8.92 centimeters, right? So that's basically what we're being told here. Remember, if we had to just calculate, the volume of this entire tin, right? We just that volume or that we would have obtained if maybe, for example, they gave us a height, maybe that they said that the height is equal to 12 centimeters. Okay, if we say pi times radius squared times the height, okay, that basically says that if we were to fill up this tin with paint to the top, that is how much this tin can hold. But in this situation, we're not filling up the tin to the top. Okay, it's just obviously to 90% of its capacity. So that's now what we need to shift our thinking to. We're not going all the way up to the top. We're just filling it up to 90% of the tin's capacity. Okay, so let's look at question A. It says determine what is the radius of the paint tin. Okay, this is very easy. Okay, if you want to calculate the radius of the paint tin, and we already given the diameter. Okay, so to get the radius, we just know that radius is equal to diameter divided by 2. Okay, so therefore we're just going to take that 8.92 centimeters divided by 2. Therefore the radius is equal to 4.46 centimeters. So that's basically the radius of this painting. So from there to there, it's just equal to 4.46 centimeters. That's the radius. Okay, let's have a look at the next question. It says the highest level reached by the paint in the tin. Okay, you may use the following formula. So we want to determine what is the highest level reached by the paint in the tin, right? So now obviously they told us that the paint is just filled to 90% of its capacity, right? Okay, and from there we are told that we just want to determine what is the highest level of the paint. So they want to determine what is the height of the paint. Okay, what is the height of the paint? Not the height of the tin. What is the height of the paint? So how will we be able to, determine the height of the paint? So the first thing that we already know that to determine the volume, okay, how much paint this tin can actually hold, we know that volume is equal to, I'm actually trying to move closer to this so that you guys can see me. Okay, so to calculate the volume of the tin, to determine how much paint this tin can have, we know that volume is equal to pi multiplied by radius squared multiplied by height. I think we all now know this by now. We've been doing a lot of video tutorials where we obviously using the formula for volume, right? What are we given here? We are told that, look at this here. They are telling us that the capacity of the tin is equal to 1,000 centimeters cubed. So that's basically telling us that the volume of this tin, they're giving us that the volume. They're actually telling us that the volume of the tin is actually equal to 1,000 centimeters cubed. We are being given the volume. All right. Okay. So now how can we work with this information that is given to us, right, to help us determine the height of the paint? So I'm going to first start off with what we know. Okay. We know what is the volume of the tin. We know what is the radius of the tin, and we calculated it to be 4.46 centimeters, right? And we do not know what is the height of the tin, right? So I'm just going to highlight this in blue. We do not know what is the height of the tin. That is the height of the tin. We do not know what that height is. Okay, we do not know. So that is what we can actually start off by calculating. What is the height of the tin? What is it? Okay, how can we figure that out, right? So then here it becomes a bit easy. Okay, we already know what is the volume of the tin. The tin has a capacity of holding 1,000 centimeters cubed of paint, equal to, what is pi Okay, let's see if they told us what to use as our pi. Yes, they said that we must use 3.142 multiplied by, what is our radius? Our radius is 4.46 centimeters squared multiplied by the height of the turn, right? We do not know this height. That is what we're trying to figure out. We do not know what it is. So obviously we have to figure out what that is, right? So what do we need to do at this point? We're going to obviously simplify the right hand side. So if you take 3.142 multiplied by 4.46 all squared, you will actually have that this is 1,000 centimeters cubed is equal to, so this is going to be 62.4994072 centimeters squared multiplied by that height of the tin. Okay, and then what do we need to do now? What's left for us to do now? We want to isolate this because we're trying to solve for the height of the tin. What is this height of the tin, right? We're trying to determine the height, the total height of this tin, right? So for us to determine the total height of this tin, that means that we need to obviously isolate the H10. And how do we isolate H10? We basically need to do the inverse operation of what has been done here. So because we are multiplying by 62.4994072, that means that to get rid of that 62.4994072, we just need to divide by it, okay? So if you divide by that, 62.4994072 centimeters squared. What you do on the left hand side or right hand side, you need to do on the left hand side 62.4994072 centimeters squared. Then this cancels with this because that divided by that is 1. Okay, that means that now our final answer is going to be, right, the height of the tin is just equal to, we're going to take that 1,000 centimeters cubed divided by 62.4994072. It's going to be 16.00015,176 centimeters, because okay, centimeters cubed divided by centimeters squared, you'll be just left with centimeters. So that's basically telling us that okay, the total height of this tin is equal to, I'm just gonna make it 60 centimeters. Okay, it's 16 centimeters. But now remember, we don't want the total height of the tin. The question was not asking us for the total height of the tin. What we've just figured out now is that if we had to, based on the information that was given to us here, right, if you had to fill this paint up to the very top, okay, it has the capacity of holding 1,000 centimeters cubed of paint. But then remember, in a real life situation, they won't fill up the paint until the top. Okay, that just wouldn't make sense because then our paint would, spill up and then stuff like that, right? So that is why they just said now that obviously when they filled up this paint, they've just filled it up to 90% of its of the tin's capacity. So now how would we then get the height of the paint? So now we just want to determine what is the height of the paint. Okay, so for us then, for question number B, to get the height of the paint, okay, the height of the paint, we are told that it is equal to 90% of the height of the capacity of the tin. So obviously we need to relate height of the paint with height of the tin. So it's going to be 90% of the height of the tin, because the height of the tin, right, is the full capacity of that tin, right? If you're actually looking at it in that sense, okay. So if you want then the height of the paint, it will be 90% of the height of the tin. So what is 90%? 90 over 100 multiplied by what is the height of the tin? It's 16 centimeters. And then what would be the answer? 14.4 centimeters. Okay, so what does this mean? It just means that, okay, the height from there to there is equal to 14.4 centimeters. So that's just the height of the paint in the tin. Okay, question number C. It says in liters, right? Determine in liters the amount of empty space in the tin, right? So the question is asking us that we need to calculate the amount of the empty space. That's the empty space. Remember here, right? We don't have any paint in this space there that I've just highlighted in green. Okay, so the question is asking us to determine in liters, right, the amount of empty space in the tin. So in other words, this question is asking us to actually calculate what is the volume of the empty space. What is the volume of this empty space, right? So here, remember, okay, this is still a cylinder, okay? If you want to calculate what is the volume of that empty space, okay, all that we need the radius, we need the height of the empty space, right? So I already know what is the radius of the cylinder. Okay, we already know what the radius is. We found that it's 4.46 centimeters. But now all that we need to do to be able to calculate the volume of this empty space, we just need the height of the empty space. Do you see what I'm doing there? What's the height of the empty space? Okay, right? So to determine the height of the empty space, what do we need to do? This is question number C. So the height of the empty space, okay, is going to be equal to, we're just going to take the height of the tin, okay, the height of the tin minus the height of the paint. Okay, so the height of the tin minus the height of the paint. So it's 16.00 centimeters minus the height of the paint, which is 14.4 centimeters. Okay, which is going to be equal to 1.6 centimeters. So then the height of that empty space is just equal to 1.6 centimeters. And then from there, we are able to now calculate what is the volume of that empty space. So to find the volume of the empty space, it will be equal to pi, which is 3.142, multiplied by the radius. It's 4.46 because we're still working with the same cylinder, centimeters all squared, times the height of the empty space. Okay, right. So the height of the empty space, let me actually do this. So to get the volume of the empty, it'll be pi times radius squared times the height of the empty space. Okay, so it's going to be 3.142 multiplied by, what's the radius? 4.46 centimeters squared multiplied by the height of your empty space, 1.6 centimeters. Okay, so 3.142 times 4.46 all squared times 1.6. Therefore, the volume of the empty space is 99.999. I'm just going to leave it in 3 decimal places. Centimeters cubed, right? Centimeters cubed. But remember, they asked for us to obviously convert this volume into give the final answer in liters. Now, this is where we can obviously now apply those 2 equations that are asked you guys to memorize in case they do not give them to you, right? So I hope you guys are listening to these tips that I'm giving you, right? So what is it? We know that 1 meter cubed is equal to 1,000 liters. 1 meter cubed is equal to 1,000 liters. And we know that 1,000 centimeter cubed is equal to 1 liter. You need to know these equations off by heart. Okay, so now which one are we going to use? Okay, which one are we going to use? We can just use this one, okay, where it relates liters and centimeters cubed. So what's the final thing that we need to do to convert these centimeters cubed into liters? You multiply by what you want. We want liters, so we're going to multiply by 1 liter, divide by obviously the other value there, which is 1,000 centimeters cubed. So we divide by what we have. Okay, so if you take that 99.123 and you divide it by 1,000, what do you get as your answer? It's just 0.0 and then 5 liters. Okay, so 0.0 and then 5 9 liters. Okay, so here, I mean, obviously with the rounding off, okay, you'll just have to read instructions that are given in the exam. I'm just keeping my values like this because I just want to maintain accuracy. So I can also just write that as this is approximately equal to 0.1 liters. Okay, so that's actually the volume of that empty space. Okay, that empty space has the capacity of just taking 0.1 liters of paint. Okay, so I hope you guys enjoy this video tutorial, right? Where we actually have to now, determine what is the unknown length of, unknown height of the paint inside the tin. If they've told us, the tin or the paint in the tin is filled to 90% of its capacity. Okay, so what were we supposed to do there? Okay, the nice part about this question, we were given how much, what is the volume of this tin? Okay, what is the capacity of this tin? They told us that this tin can hold 1,000 centimeters cubed of paint. Okay, so that's the first thing we need to do. Obviously, work with that value that is given to us to first help us calculate what is the actual height of the tin. Okay, once we then have the actual height of the tin, then we can work with that height of the tin to determine what is 90% of the height of the tin, which is the height of the paint. Okay, so I hope you guys enjoyed this video tutorial, ladies and gentlemen, right? In the next video tutorial, we are going to be looking at cooking conversions, right? So if you're given a recipe that you're working with and you need to now convert from cups to milliliters, from teaspoons to milliliters, how do we do that? Cooking conversions are very important. Okay, very important. You need to understand how we convert from your imperial to your metric. Okay, how do we do these conversions? And I promise you, if you just remember, multiply by what you want, divide by what you have, literally, you cannot fail this exam. I promise you. Just hold on to that, and then you know how to create equations as you're going with the statements that are given to you, then life becomes a breeze. Guaranteed. Okay, so I'll see you guys on the next video tutorial. We're moving on to, cooking conversions. How do we convert, okay, if we are given this conversion table? All right, so I'll see you guys on my next tutorial.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.